So, chain rule. So I have 3x plus 5 squared times the square root of x plus 1. So first let's handle the square root, because we really haven't looked at anything with the square root. How can I rewrite this square root to make it look more familiar, something like we've worked with before? Oh, power over root, right? Power over root, close enough. So I can rewrite this with an exponent, right? And then I can just use power rule. So I have f of x, haven't taken any derivatives yet. F of x equals 3x plus 5 squared times, what is the square root written with an exponent? 1/2, right? X plus 1 to the 1/2 power. Alright, so now I have it more in a form that I'm used to working with. So we can go ahead, let's find the derivative. So I want to take f prime of x. And so looking at it, big picture, what rule will I have to use? Product rule, right? I'm multiplying this thing times this thing times this thing, so I'm multiplying together, so I will have to use the product rule. When I take the derivative of this first piece, what rule will I have to use? Chain rule, right? I have an inside function and I have an outside function. And then same thing with the second piece. When I take the derivative of the second piece, I have an inside function and I have an outside function. Right? So just a little bit of crazy power rule going on. So let's take the derivative. So product rule says I'm going to take the derivative of the first, and we said we were going to use chain rule. So derivative of the outside is going to give me what? 2x, so 2 times 3x plus 5, right? Derivative of the outside with the inside still stuck in it, times the derivative of the inside, so times 3. And then product rule says to multiply that times the second part, so times x plus 1 to the 1/2 power. Plus, now I'm going to do the opposite. I'm going to take the second function and take its derivative, again using chain rule. So I'll have to take the derivative of the outside, leave the inside still in it. So the derivative of my outside function is going to be what? So what is my outside function? X to the 1/2 power, right? It was the square root. That thing's on the outside. So looking at just x to the 1/2, if I take the derivative of that, just using power rule, what is the derivative of x to the 1/2? 1/2 negative 1/2, right? Reducing that power by 1. So 1/2 x to the negative 1/2. So chain rule says to take the derivative of that thing, but leave what's on the inside on the inside. So the derivative of the outside with the inside still in it is going to be 1/2 x plus 1 to the 1/2, negative 1/2, times 1. Why times 1, Miguel? The derivative of the inside, the derivative of x is 1. The derivative of 1 is 0. So this is times 1. I'm going to put my little 1 right there. And then product rule says after I've taken the derivative of that second piece, multiply it back times the first piece. So I'm going to multiply it times 3x plus 5 squared. And I'm going to make this a little bit prettier. I have some constants I'm going to pull out front. So I have 6 times 3x plus 5 times, I'm going to leave that as a half. You can put it back as the square root if you want. Plus my constants, I have a half and I have 1, which is just a half. And I'm gonna leave it like that. X plus 1 to the negative 1/2 and 3x plus 5 squared. Now I'm fine with leaving it just like that. This is a sufficient answer for me. But we're going to take it one step further just for other classes. You might have to do it. Some people are not okay with this negative exponent. So what does a negative exponent do? Little algebra review. It would be a fraction, right? It forces it to the bottom. So 3x plus 5 has a positive exponent, so it would stay up top. 3x plus 5 squared. Then my 1/2, the 2 would be on the bottom. and this would be x plus 1 to the positive 1/2, or the square root of x plus 1, either way. But I'm fine with this answer right here. Just need to know that you can take the derivative. Okay? Ta-da!